Hello, Maurieo. In this video I'm going to be calculating a missing line. I call it a missing line, but some people call it a vector or a join or an inverse, and there are all sorts of other names, but I'm going to stick with missing line because that's what I grew up with. I was taught how to calculate missing lines. All those other things came later for me. So here it is, how to calculate a missing line. And here's the example I'm going to use, and here's my little 15C calculator that I'm going to use to do it on. So let's have a look at it. What we want to do is find out the bearing and distance between post A and post B. We have traversed around through these marks here and done some little hanging ties out to the post from IT6 and from IT7. So what we need to do is to calculate from post A to IT6 to IT7 to post B, and then calculate the missing line between post A and post B. Now to do that we have to write the things down, and we have to get all the bearings going the wrong way. Now 336 degrees 15 goes from 6 to A. We want to go from A to 6, so we must take 180 degrees off that, which is 156 degrees 15 for 42.71 meters, and that's what we've written here. Then from 6 to 7 the bearing's going the right way, 86 5130 for 146.27, and then from IT7 to post B, 323 degrees 28 for 50.16 meters. So there you are, that's it's written out. In previous videos I've shown you that the delta N can be worked out easily using the cos of the bearing times the distance, and delta E the sine of the bearing times the distance. However, I'm going to do this using the fabulous HP 15C calculator. So first of all I'm going to just clear the sigma area, the sigma statistic memories, and away we go. So you can see how easy it is. 156.15, take that, make that into hours or degrees and decimals. 42.71, going to make that into rectangular, and there we have our delta N, where it appears that I have omitted to put the negative sign there, so we'll just fix that up now. There we go. Negative 39.093 seems fine. I'm just going to push the sigma key and just do an XY, and that should give us the 17.201. It's the delta E. So let's move on now to the next one. 86.513 to degrees and decimals. 146.27 to rectangular. 8.016, push the sigma key. You can see how it tells us that that's the second time we've pushed the key there. XY that 146.050 gives us our easting if we care to write that down. Obviously using this marvellous calculator we do not have to do that. And on finally to the next one, 323.28 to hours or decimal degrees, 50.16 to rectangular, 40.304. I've written that one down correctly. Push the sigma plus key, which accumulates the x's and y's. XY 29.860. That's all good to go. Now we just recall sigma plus, and that gives us our accumulated totals here, like so. And then we want to convert that to polar, 133.710, which gives us the distance. I've chosen to keep it at the 0 rather than the 5. Let's XY that. That's in degrees and decimals. We want it in degrees, minutes and seconds. 860234. So then we put our final rounded bearings and distances. So I've rounded that up to 860230 and 133.71. Put that on our diagram and finalized. There we go. What could be easier than that? Quite easily done. QED. And now, just for a little bit of added extra, while I've got your complete and utter attention, Maurieo's tip of the day. Well, 2 tips as it turns out. And here it is here. If you can draw it, you can calc it. Early on when I started in surveying, they told me that if you could draw something, then you most certainly could calculate it. And now, as simple as that may sound, it is quite a good tip, because if you're having difficulty with a problem, if you first work out how you can draw it and then follow the drawing process, you can calculate it by following the same process. Work out how you can draw it, then calculate it. And just to follow that up, a little bit of added extra for experts. Check your calculations with an accurate CAD drawing. If you want to have an added check to your drawings, just draw them very accurately with CAD at a one-on-one. And then, like with the missing line, you can put all the bearings and distances in, and then just click on the line to find the properties button, and if you've got things set up right, it'll tell you the bearing and distance. Total coordinates, key in the coordinates of each end, join them with a line, check on the properties button, and find the bearing and distance between those 2 coordinates. So there you go. Tip of the day.